Hey mathletes, so in this video we're going to look at creating scatter plots and looking at correlation. So here we got a situation, the number of people that go to the movies and the amount of money spent on snacks. So a scatter plot is literally just a graph of the data points. So X will be the number of people and Y will be the amount of money spent on the snacks. So 2 people, $10. So all we need to do, go to the coordinate 2, 10 and put a dot. So 3, 20, 425, 540, 860, 745, 645, and 215. So this is a scatter plot. So the reason we make scatter plots is so we can see the trends in data. That means, are they generally going up? Are they generally going down? How are the two things connected? So obviously we can say that the more people go to the movies, the more money is spent on snacks. Okay, so this is called a positive correlation. The other reason we do this is so we can make predictions about future values. So on the table, there's no 9 people, but we can tell if we had 9 people, we'd be spending somewhere between $60 and probably $80 on snacks. If we had 1 person, we'd know we'd spend somewhere between $5 and $10 on snacks. You can see when you make the scatter plot that the scatter plot itself is not necessarily a function, because for the x value of 2, we have 2 different y values. But we could draw a line through this and come up with a function for that. Have an equation and use that equation to predict values. We make scatter plots so we can look at the correlation between the 2 variables. Correlation means how are they related? As in this case, a positive correlation. As variable A increases, variable B also increases. So this could be the number of people that go out to dinner and the amount of the bill at the end of the night. Or, like we just saw, the amount of people that go to the movies and the amount of money spent on snacks. More people, more money. A negative correlation is when variable A increases, but variable B decreases. So this could be the amount of gas in the tank compared to how many miles you drive. So when you drive more miles, the amount of gas in the tank goes down. Sometimes you graph something and it has no correlation whatsoever. It just looks like a giant mass. It's not going up, it's not going down, it's not in a line, it's not in a curve. This is no correlation. So an example of this would be shoe size versus grade point average. There's absolutely no connection between the 2 things whatsoever. Now, in addition to the type of correlation, we're also going to talk about the strength of the correlation. So here we have a perfect positive correlation. These coordinates are exactly in a line. So the line equation you draw is going to be exactly through every single one of those points. We'll look at these R values in a second. Strong correlation means if you drew a line through it, all the points would be pretty close to that line. Moderate to weak means if you did draw a line through the data set, they're a little more spread out. And again, this time you can't draw a line through it because it doesn't go anywhere. It's just a cloud. So this is no correlation. The R value that you see here, you're not going to come up with it. You can, it's an incredibly long and complicated formula, but you're not going to. This is going to come from either the calculator or the program that you're using. Google Sheets or Excel or Desmos will tell you how strong a line equation it is that passes through the points. So when we talk about the correlation of a scatter plot, it's either positive, negative, or no correlation, and also the strength, perfect, strong, moderate, or weak.